and good morning. We are here from my backyard on tape delay, but here's how this works. There's a question about converting a circle from a rectangular system to a polar system. So the things that we need to remember, I'm working right now, x equals r cosine of theta, and y equals r sine of theta. So these are important things to remember. Now, from a circle, you also ought to remember that when it comes to your circle equation, that we have x minus h squared plus y minus k squared equals r squared. And so that these things combine with this, all of it's connected, making it all work together. In this right here, we can see from our equation that r equals 4. Also, our center is at 0, negative 4. So, yeah, so our center, remember, is at h, k, and the radius is r. So r is 4, and that's going to come into play a little bit later, because when you have a polar equation, you want it r as a function of theta, and so we'll have to get there. But so real quick, since r is 4, then we can change x squared. Well, actually, let's just go with, hey, this is what x is. So we'd have r cosine of theta squared plus r sine of theta plus 4 squared equals 16. So all we're doing is just changing x to r cosine of theta and y to r sine of theta, exactly like we know how that goes. If we multiply this, it's going to be r squared cosine of theta, cosine squared of theta, plus r squared sine squared of theta, plus, and then so we'd have that be just on the side. Let's just do this on the side. R sine of theta plus 4 squared means we're going to multiply it by itself, like so, which means we have r squared sine squared theta plus 4r sine theta plus 4r sine theta plus 16. So all we're doing is foiling that out. So now there's 2 4r sine thetas, so that means actually 8r sine theta, so 8r sine theta plus 16 equals 16. So now with this, right here on this one, we can factor out an r squared, and then we have cosine squared theta plus sine squared theta. That's important. We can say, just bring this down, plus 8r sine theta. We can subtract 16 from both sides, minus 16, and that will be 0, and that will be 0. So now we're here at 0. This is 1, so that means we have r squared times 1, and then we can also subtract 8r sine theta from both sides. So then we have r squared times 1 equals negative 8r sine theta. We divide this by r, we divide this by r, and then we end up with r equals negative 8 sine theta. And that's going to be our equation on how that works out. Now, there is a faster way to do this without going through the conversions, and that is understanding certain circles in polar coordinates. If the circle is sitting here up against the x-axis, and you have right here, this is going to be r, because that's your radius from the center to the edge, okay? Then whatever this is going to be r equals, and well, actually, you know what, let's to make it better, let's call this big R, just so that way we can distinguish between the two. So this is some number, so that r will equal 2 times big R cosine of theta. So that means, like, let's say if r equals, let's say this was 3, then this would be r equals 6 cosine of theta. And this is just an example, okay? So I'm just pulling that out of the air. Okay, I know normally I pick 5 as my examples, but you know, hey, we could do that some other time too. But that's the idea. So it's just for example, okay, which means this. Now, this problem right up here, okay, we know that the center is at 0, -4. So 0, -4 would be -4, like so. And we know our radius is 4, so that means it goes up 4 and down 4 and over 4 and over 4. And so we get our circle like so. And so this one really looks like that. And we just saw what happens. But so the idea is that if this is, again, if this is big R, then we'd say little r equals 2 or -2, because it's below, -2 big R sine of theta. In our case, that was 4, because we were at -4. This was our problem that we just did. Right here. If it's at -4, that means then if we follow that pattern, which said, hey, r equals -2 big R sine of theta, well then big R is 4. So we'd say, hey, -2 times 4, -2 times 4 sine of theta. So we get r equals -8 sine of theta. And then this idea is just that r is going to be your, r is a radius, so we want that to be positive. But similarly, if it's sitting on top of the x-axis like so, as opposed to the bottom one, so this one's negative, this one's going to be positive, so this would be little r equals big R, 2 big R sine theta. And then this one, since it's to the left as opposed to the right, this would actually be -2 big R sine theta. So it's just something to kind of speed it up, to say, so when I looked at this problem myself, this is what I thought. But this is how you can go through the conversion to get there, and that's pretty useful. So, hey, have a good day. Send more questions my way. I like doing this, I really do. I'd rather do it in person, but hey, this is something. All right. And Joshua says bye too.